Okay, so let's talk about the stars and pluses that show up in these basis sets. And even though there are other types of basis sets, these same sorts of principles apply to them as well. So the stars add what are known as polarization functions. And what these are adding functions of one higher L value. So for example, if we have an s orbital, we add a p orbital to this s orbital. That allows it to distort its shape a little bit. Polarization allows for distortion. So this is useful because as atoms come together to form molecules, the orbitals don't stay necessarily exactly the same shape that they were when something is just an atom, right? The orbitals may bend towards or away from certain parts of the molecule. You have electronegative atoms that are going to pull electrons towards them, electropositive, that are, where the electrons maybe are going to be pushed away from them a little bit. And so these polarization functions allow your, spherically symmetric s orbital to, say, distort a little bit and become more oval shaped because you've added a little bit of a p orbital to it. Or if we have, right, so we have an s and we add a p orbital to it. Or say we have a p orbital, we add a d orbital to it, and maybe we add it partially, and that allows the p orbital maybe to be pushed away from a particular direction. So these polarization functions are important, but of course we're adding more functions, and that's going to make the calculations take longer. All right, and then the last thing to talk about are these pluses. Oh, and the difference between 1 star and 2 stars. So 1 star means you add these polarization functions. If you have 2 stars, the second star means that we add it to hydrogen atoms too. So generally you have a lot of hydrogen atoms, particularly in organic compounds. So if you don't need them for the hydrogen atoms, it can save you some computation when you have a lot of them in your calculation. Okay, so the plus plus. So these functions, the plus plus functions, these are what are known as diffuse functions. And same thing as with the polarization functions. 2, the second plus means do it for hydrogen 2. And the diffuse functions are quite a bit similar to having extra zeta values. They allow you to, to adjust the long range interactions, right? So this is especially important for things if you have, say, like van der Waals forces that you're trying to capture in your calculation. So diffuse functions are things that are, typically much larger than your original functions, right? You're adding a little bit of the very large wave functions. And, it's a very, very hand-wavy way of talking about this. I'm not, 100% clear on exactly mathematically how this is done. Let's say adding large orbitals or something like that. Right, and so the pluses indicate that we're adding this sort of long-range interactions, and that can help model these behaviors. The polarization functions can be very important in modeling things where you have the electrons being pushed or pulled in particular directions. Say things you have like anions or things that are very electronegative pulling on things.